Let's discuss in our chapter 20 about petrochemicals and polymers, fossil fuels. Its overview. Major fossil fuels are coal, natural gas, petroleum. Importance critical to modern living. Consideration economic impact, practical applications, environmental concerns. Petroleum separation, fractional distillation, process used to separate petroleum into different fractions, allow extraction of various petroleum based products. Polymers, fundamental concept. Definition of polymers: long chain molecules constructed from smaller molecules called monomers, classified into two primary types: addition polymers and condensation polymers. Addition polymers, key characteristics: formed from monomers with C double bond C, homopolymers, single monomer type, double bonds open during polymerization. Then we have example of polypropene. Properties: easily shaped by melting, molding, versatile material used in plastic crates, ropes, lightweight, strong applications. Then we have condensation polymers, formation process. Monomers react, eliminating small molecules, usually water. Two primary types: polyamides and polyesters. Specific polymer examples: nylon, polyamide. Historical context: developed by DuPont in 1930s. First synthetic fiber. Composition: copolymer of diamine and dicarboxylic acid. Applications: clothing, shirt, ties, sheets, ropes, nets, gear wheels. PET, polyester. Composition: made from two monomers, diol, alcohol group, dicarboxylic acid. Polymerization forms ester links. Water eliminated during this process. Some enzyme technology in plastic recycling. PET-ACE enzyme discovery. Origin: Japanese recycling plant in 2016. The bacteria the used is Ideonella sequensis. Capabilities: breaks down PET plastic, use PET as energy source. Potential: revolutionary recycling technology. Enzyme advantages: they are non toxic, biodegradable, producible in large quantities, potential for efficient plastic waste management. Some key reaction types: condensation reactions, two molecule combine, produce larger compound, small molecule, usually water, eliminated. Functional group reactions: amide link formation, carboxylic acid plus amine group produces amide, water, eliminated. Ester link formation: alcohol plus carboxylic acid produces ester, water, eliminated. Now let's talk about environmental considerations. Plastic waste management, recycling challenges, emerging enzyme technologies, sustainable alternatives to fossil fuel based products. Now, petrochemicals and polymers. Plastic, fundamental characteristics, definition and properties. So, plastic polymeric material characterized by plasticity. Key properties are moldable under heat and pressure, versatile material with multiple applications, can be strong yet lightweight, low heat conductivity, and varying flexibility. Advantages: applications such as used in soft drink bottles, food containers, insulating foams, plastic bags, garden hoses, 3D printing, prosthetic limbs, respirator, mask. Plastic waste management. Environmental challenges. Major concerns non biodegradable, increasing global waste, potential environmental contamination. Waste disposal strategies. Reuse and recycling. PET bottles can be recycled. Deposit schemes encourage bottle returns. Optical scanners help sort plastic types. Then we have disposal methods. Incineration requires controlled high temperatures greater than 850 degrees centigrade. Risk of toxic fume release. Potential environmental hazards. Landfill disposal. Limited space, non biodegradable material persist. Research into biodegradable plastic ongoing. Ocean plastic pollution. It includes microplastic. To the most types are nurdles, pre production plastic pellets, microbeads, tiny plastic spheres in cosmetic. Then we have garbage patches, concentrated plastic debris zone located in major ocean gyres. Significant environmental threat. Then we have plastic recycling process. So recycling steps includes number 1 sorting plastic by type, then granulation of recyclable material, and then melting and remolding into new products. Hydrolysis mechanism. Chemical breakdown of polymer bonds reverses original condensation reaction. It allows potential monomer recovery and reprocessing. Some key environmental recommendations include reduce plastic packaging, eliminate single use plastic, maximize reuse and recycling, develop alternative disposal methods. Some potential solutions, research directions, use biodegradable plastics, photo degradable materials, also good. Microorganism based plastic breakdown is crucial, and use of advanced recycling technologies. Some recommended actions minimize plastic consumption, support recycling initiatives, choose sustainable alternatives, raise environmental awareness. Some important terminologies microplastics, plastic pieces less than 5 mm, causing environmental contamination. Hydrolysis, chemical reaction breaking polymer bonds using water. Nurdles, pre production plastic pellets. Microbeads, tiny plastic spheres in cosmetic products. Now let's talk about petrochemicals and polymers, petroleum fractions, and distillation. So, fractional distillation process, key concept here is that it is the separation technique of petroleum into different hydrocarbons groups based on their boiling points. Petroleum is heated 350 to 400 degrees centigrade and pumped into a fractionating column. Separation occurs as vapors cool and condense at different heights. Let's talk about petroleum fraction table. Refinery gas. Carbon atom use C1 till C4. Boiling range is below 25. Key uses is bottled gas for heating cooking. Then we have petrol, gasoline. Carbon atoms from C4 till C12 can be used. Boiling range is 40 to 100 and the key uses is fuse for cars. Naphtha C7 till C14, boiling range 90 to 150 and uses is in chemical feedback. Kerosene, carbon atom C12 till C16, temperature 150 to 240, used in jet engine fuel heating oil. Then we have diesel oil, carbon atoms C14 to C18, temperature around 220 to 300 degrees centigrade, and used in diesel engine fuel. Then we have fuel oil. Carbon atoms are from C19 to C25. Temperature is from 250 to 320. Ship and home heating used in. Then we have lubricating fraction C20 to C40. Temperature 300 to 350. Used in waxes and polishes. Then we have bitumen greater than C70. Above 350 is the temperature, and the usage is in road surfacing. Some important observations: vertical gradient, chain length, boiling point, and viscosity decreases from bottom to top. Volatility increases from bottom to top of the column. Supply versus demand. Lighter fractions, petrol, gasoline, have higher demand. Heavier fractions have lower demand. Composition varies between different oil fields. Now let's talk about catalytic cracking. Purpose: convert longer hydrocarbon chains into more valuable shorter chains. Obtain alkenes and hydrogen from longer alkane molecules. Cracking process: it is the breakdown complex hydrocarbon into simpler, more useful compounds. Produces shorter alkenes, and hydrogen. Let's talk about polymers. Types of polymerization. Addition polymerization. Example is polyethene. Monomers join without losing any atoms. Simple joining of identical molecules. Let's talk about condensation polymerization. Example: nylon, polyamide, polyester, PET. Monomers join with loss of small molecules. Example: water. Let's talk about polymer classification. Polymer type: polyamide and polyester. Polyamide polymerization is condensation, as well as in polyester it is condensation. However, the example of polyamide is nylon, and for polyester it is PET. There are some natural polymers as well. Protein are the natural condensation polyamides formed from amino acids, monomers. Now let's talk about plastic and environmental challenges. Some key environmental issues. Number one, biodegradability. That is the ability to decompose naturally. Most plastic do not break down easily. Significant pollution problem in land and water environments. Then we have disposal challenges as well. Accumulation in the oceans, long-term environmental persistence, limited breakdown of mechanism. Then we have pollution concerns. Burning plastic create additional environmental pollution. Synthetic polymers do not decompose naturally. Let's talk about polymers. Introduction to polymers. Definition: large organic molecules composed of repeating units called polymers, found in both natural and synthetic materials. Essential in living things and modern technology. Types of polymers: we have some natural polymers such as protein, carbohydrates, wood, and natural rubber. Then we have synthetic polymers, which is plastic, ubiquitous in modern society, used in car components, aircraft parts, packaging, clothing. Now let's talk about polymer classification. Homopolymers contain only one type of monomer. Example: polyethene, polypropene, polychloroethene. Copolymers means they are composed of two or more different monomers. Some examples here are nylon and biological protein. Biological protein made from 20 amino acids. Let's talk about addition polymerization. Key characteristics involves alkene molecules with C double bond C, monomers join to form long chain polymers, requires high pressure, elevated temperature, and catalyst. Polymerization process. Specific polymer examples. Number one, polyethylene. Properties are chemically resistant, tough and durable, excellent electrical insulator. Number two, I have polypropene, which is also known as polypropylene. Similar structure to polyethylene, methyl group attached to every other carbon atom. Then we have polychloroethene, PVC, stronger and harder than polyethylene, ideal for plumbing pipes. Next, we have polytetrafluoroethene, PTFE. They are extremely stable at high temperatures, create slippery surfaces, commonly known as Teflon. Now let's talk about polymer properties comparison table. So polymer, we have polyethylene. The monomer is ethene. Key properties or characteristics, they are tough, durable. Common uses, used in plastic bags and bottles. Then we have polypropene. The monomer is propene. Key properties, they are strong, versatile, and the common uses are crates, boxes, and rope. Then we have PVC. Monomer is chloroethene, hard and strong properties. Common uses, used in pipes and guttering. Then we have PTFE, tetrafluoroethene, is a monomer. Key properties are they are non-stick and heat resistant. Common uses are in frying pan joints. So key terminologies to learn. Number one, monomer. They are small molecules that can polymerize. Polymerization, chemical reaction, joining monomers. Then amino acids, organic compounds with amino and acid groups. Condensation reaction, process of forming polymers. Now we have some representation techniques. Monomer to polymer conversion. You can draw monomer with double bonds, then remove the double bond and create single bond between monomers. From polymer to monomer reconstruction, identify repeating units, isolate unit with two carbon atoms, redraw as molecule with double bond. Once we solve in our past papers, then you will be having more practice and it will be more easy to learn and keep into your mind. Some practical consideration includes careful attention to structural details, understanding of side groups, recognizing chain formation mechanism. With this, we have finished our this lesson. See you in our next lesson.